Assalamualaikum and good day to all the panel and my friend. My name is Noreen Aqilla Binti Kamaruzaman and my supervisor is Associate Professor Dr. Muhammad Amri bin Sulaiman. For today, I would like to present my FYP1 project entitled Experimental Study on the Tool Performance during turning Nimonic C-263 with Cryogenic C02 Coolant. For the introduction, Nimonic C-263 is the workpiece material that been used in this turning process. Nimonic C-263 consists of 50% of nickel and another 20% of chromium. This material, nickel-based superalloy family that coupled with the lower percent aluminium, cobalt and titanium, they are mostly used in the heavy industry. Example like aerospace, marine, power plant and nuclear industry, since this material work efficiently even at the high stress environment of the long term. Excellent temperature strength such as high hardening, tensile strength, thermal fatigue resistant to the corrosion, thermal stability and oxidation have made this alloy can make a critical part with the excellent mechanical properties to sustain the extreme temperature range. Next, to machine Nimonic C-263 a material workpiece by using high-speed turning. In this high-speed turning is the machining of the external surface of the workpiece by rotating a single point cutting tool to remove the material from the workpiece. This high-speed turning is around 2 until 50 times more higher than the convenient machining cutting speed. In this, high-speed turning can reduce the machining time and cost, increase the productivity that can achieve by the higher removal rate (MRR). Then, when machining at the cutting condition, it will be lower the tool wear rate and thus extending the tool life. Just using high-speed turning is not enough to study on the tool performance during turning Nimonic C-263. Cryogenic C02 coolant is the neutral coolant. Basically, coolant will be exist as the cutting fluid. Basically, coolant fluid will be helped to increase the tool life, enhance the surface quality, and decrease the cutting force. But convenient coolant are failure of lubrication at the higher metal removal rate and will be cause the environment pollution. So this cryogenic C02 coolant is the clean technology and environmental friendly. It also are not give dangerous effect to operator. This cryogenic CO2 coolant are technique done at the zero temperature which -78 degree Celsius. The problem statement in this project, first, Nimonic C-263 alloy is the great demand in the heavy industry, but the very difficult are being observed while machining in this Nimonic C-263 alloy at the various stage due to its the low conductivity at the higher temperature, work hardening tendency, and rough particle form the formation on its structure. Due to high temperature during machining, the heat produced at the cutting zone that can be shorten the life of the tool. Second, problem with the conventional coolant are failure as the lubrication at the higher metal removal, and also conventional cutting fluid are ineffective in reducing the cutting temperature at the cutting zone. Thirdly, most of the cutting fluid will damage the work safety standard and also will be hard the machinist's help. That will be harm the manufacturing rate and environment pollution issue. The objective in this project, first, to identify the significance of the cutting parameter on the tool life during turning Nimonic C-263 alloy under the cryogenic CO2 coolant. Second, to develop mathematical model for the tool life through statistical analysis. And thirdly, to optimize the cutting parameter towards the tool life of the carbide insert. Regarding to the literature review on my screen, I would like to summarize. The Nimonic C-263 have the higher percent of cobalt between 90% and 21% that will improve the material strength and high plastic distortion that make the material harder to machine. Then develops of BUE will be blur the surface integrity and lead to the tool failure. The selection of the cutting parameter will provide the effect on the machining quality, tool life, tool wear, and machining efficiency. The relationship between the tool life and the machining parameter is the tool life will be reduced when the cutting speed is increased. At here, the tool life should be considered when determine the machining parameter. And with the help of the cryogenic CO2 coolant, it's another effective approach to keeping the cutting zone temperature well below softening on the tool material. Cryogenic process will be increase the tool life by increment its toughness substantial and also resistant to wear. Based on this literature review, it has been provided that the machine tool properties, workpiece properties, cutting tool properties, and machining properties are deeply influence the machining surface integrity and the tool wear. In this methodology method used and equipment are being involved in completing in this research. Here is the project flow process chart. The first step is begin with the literature survey on establish the theory and observe the basic high-speed turning process under the cryogenic CO2 coolant condition. Then, the research is planned by using Nimonic C-263 with the high-speed machining with the help of PVD coated carbide insert and assisted by the cryogenic CO2 coolant. The cutting parameter like the cutting speed, feed rate, and depth of cut are selected based on the literature review and handbook guidance that suitable for the machining process. Then, the process parameter are selected for the further optimization by using response surface methodology (RSM). The cutting parameter select in this experiment based on the current and the past research. It was suggested that the range of the cutting speed is 120 until 220 meter per minute, and for the feed rate 0.1 until 0.2 mm revolution, and for the depth of cut 0.4 until 0.6 mm. Here is the four objective. Machining parameter were generated using RSM Bascan design by using the Minitab software. By having 3 power of 2, which is 3 input and 2 output with the 5 center point per block. So it will be generate 70 sample of the parameter that will be used machine experiment for PSM2. In this turning process experiment, the experiment continue by using the same cutting tool with the value of the tool wear VB 0.2 mm. If the tool wear are not achieve 0.2 mm, continue machine. If yes, then do the ANOVA analysis. In this ANOVA analysis, the mathematical model is developed through the ANOVA to indicate the relationship among parameter on the tool life. By conduct the experiment, can know the accuracy between developed mathematical equation and the experimental result. Here for objective 2. The optimization is conducted with the aim of the higher to life value until the pre-optimal parameter are selected. The accuracy of pre-optimal parameter is also verified by the validation experiment. Here is the objective 3. It's turning process experiment. The Nimonic C-263 with the diameter 90 mm and 150 mm length. The cutting tool used in this experiment is PVD coated carbide insert. This PVD tool used is attached to the tool holder of the CNC lathe ST20 machine. Then set the cutting parameter that have been arranged in RSM box Bascan. Then cryogenic coolant system was developed to supply the liquid carbon dioxide CO2 as a coolant. In this experiment, CO2 coolant supplied direct to the cutting zone to reduce the cutting temperature during machining process through a nozzle. After turning process experiment is done, then for the measurement analysis for the tool wear, during machining, the camera thermal image is a position on the top of the machine so that the camera are more stable while recording the machining. This camera be able to record the minimum and the maximum temperature that generate during machine. Then SEM. This machine will be produce image by scanning the surface to investigate the wear mechanism that affect the tool wear and detect excess cutting tool damage. Tool maker microscope is to measure the dimensional and angle of the machine metal. It also measure the tool wear such as a flange wear and flamphase. Lastly, X-ray diffusion, XRD. This machine normally to define the chemical deposition and crystallographic structure of the material. And the expected outcome is 1. To determine the extended tool life in turning Nimonic material. 2. To determine the optimization parameter. 3. To develop of the mathematical model. And lastly, to investigate of the diffusion possibility of Nimonic content to cutting tool by using XRD.